Hi all. Thanks for coming along. I'd like to thank the organisers for inviting me to present some of the material we developed in our look at the mathematics education system in New Zealand. The initial brief from the Ministry of Education was to try and look at the curriculum and try and understand what was good about it, what was not so good about it, what needed to change. But very quickly, we came to the conclusion that the curriculum was not the problem in New Zealand, and I'd like to talk about the information we saw and our impressions of it, and some of the things that we feel needed to be done to address these. Oh, heck. There we go. So who am I? Well, I grew up in Rotorua's Fordlands, my taonga, Ngangataha Mountain, Utitine Stream, and the wonderfully mysterious Makoia Island. My education is Malfoy Primary and then Western Heights Intermediate and then Henderson High School in Auckland. We moved up here when I just turned a teenager. You'll notice that ERO ranks Western Heights Intermediate and Henderson High School amongst the 2 or 3 worst schools in the country. I went to the University of Auckland, actually influenced by the math teachers I had at places like Henderson High School and wanted to become a teacher. So I took up the bonded teacher system and that worked out really well for me. Went to the University of Michigan after doing a PhD. Then I was a postdoc at the University of California at Berkeley, and then I was a professor at Yale for a number of years before deciding to return to New Zealand. Well, Australasia. I split a chair between University of Auckland and Australia National University, and most recently I came to Massey. Actually, while I was doing my master's at University of Auckland, I taught computer science at Westlake Boys for a couple of years. 80, 81, you might remember those are the times when computer science was basically a novel part of the curriculum, and there were very few teachers who could teach it, so that's what I did for a little while. At University of Michigan, in order to pay the bills, I actually taught mathematics for elementary school teachers. You would be quite surprised, I think, to understand what we taught in those lectures. We talked about rational, irrational numbers, different types of infinity, all those sorts of things to get actually those elementary school teachers, so that's late primary school, a feeling for the wonder and beauty of mathematics and to give them things to talk and hang their lectures about. And then I've taught and lectured in advanced mathematics pretty much everywhere in the world. So what do I know about the realities of teaching at schools in New Zealand these days? And the answer is virtually nothing. So I'm not going to give you any advice about that. What I'm going to try and do is to talk through the data we saw, the impressions we had, and things that we think need to be done. While I don't have that experience, fortunately, many members of the panel that I chaired did. So who are you? Well, I read that AMA is a professional association for the teachers of mathematics and statistics in Auckland. There are around 200 people here. So I would guess the fact that you're actively engaged in activities like this means that most of the high quality teachers in Auckland are around here. But I make the point that there are 540 schools in the Auckland region, probably 2,000 to 3,000 or more teachers of mathematics. And as noted, there are people from up and down the country here. So my worry is that I'm basically going to be preaching to the converted. But in any case, I think it's really good to have the data at hand, and these slides will be available later. The failings of our system are manifold and systemic, and I believe, and our panel believes, that teachers bear little, if any, of the blame, but absolutely have to be part of the solution. Around 200 across the country, 10,000. So yeah. I'm going to be making commentary about the systemic nature, about things in aggregate, not about individuals. So please don't hate me when I say some things which are pretty challenging. This is about the system as an aggregate, not about a particular individual out there. And as I've tried to say, the individuals out there may not be part of the problem. So I'd like to go back a little while and get some commentary I actually just got a hold of. So all measurements of mathematical understanding of pre-service primary teachers are horrific, so bad no one wants to let them be published. Sort of true for secondary school. Low mathematical standard of math teachers has been documented for umpteen years. So you can see this is a private commentary from a while ago. Book in 1950, 1970, and it's not changing. There's some fantastic teaching and learning of deep mathematics going on in a few schools, maybe even in a few classrooms in a few schools, but there are some terrible, badly taught, nil learning mathematics happening in a frighteningly large number of our classrooms at all levels. This is a commentary from an independent report from a leading mathematics educator 20 years ago. 10 years on ago, from there's a report of Paterson and Morris. 1/3 of students in first year at high school are being taught by mathematics by a teacher not qualified in the subject. And research shows that strong knowledge is particularly crucial when children are being taught mathematics. And I'll come back to that in other frames, that additional knowledge of mathematics is crucial. At that time, they looked at a sharp drop in teacher morale, which had fallen from 70% in 2009 to 57% in 2012. That is a pretty sharp drop. At that time, there were other issues around changes in the curriculum, but also some of you may remember part of that was the Nova Pay dispute. So there were a lot of anxious teachers out there at that time. Naini College principal John Russell, who taught mathematics, said that specialist science teachers were the most difficult jobs to fill. And the possibilities outside of teaching for people with math and science qualifications is much greater than it used to be. Now that was said 10 years ago. That has in part missed the huge explosion in opportunities for people with computer science skills. So the problem now is, I think, many times worse than it ever was then. Students who would have gone in and done mathematics at university and then sought alternative things such as teaching as jobs are now finding employment in computer science and those sorts of related activities. They identified the biggest problem as the lack of math qualifications and understanding in the primary sector. And I think a teacher made a pretty good observation on that report. And that was that the year 13 students are pretty intelligent. They see their teachers burning out and because of the workload. And so they themselves are not interested in the job. So, and now, okay, so here are some data from the TIMS studies and so forth, just to look. There's widespread and significant decline in student performance in schools in New Zealand. This is evidenced by our own monitoring in the system monitors. You'll see on year 5, the general trend is increasing performance. And in New Zealand, it's over the last decade or so, it's pretty flat performance. And then mathematics achievement at year 9, again, the general trend for everybody else is increasing performance, and the general trend for New Zealand is decreasing performance. So just looking at those things and the nations that we compare ourselves with, I mean, everybody looks at America and laughs at their education system. Those kids don't know anything, they're ignorant, they couldn't put. And then you look at this data and you think, oh. But some of the worst things that are going on in our school is around the inequities. And this data clearly shows that the current system actually perpetuates and indeed grows inequity in the system. You can see year 9 math achievement by ethnicity there. And it doesn't take you very long to think that there is something wrong with a system that allows this sort of about the overall New Zealand, but I want you to observe here that this top performing cohort of students has been growing significantly in New Zealand over the last growth in the proportion of top performing students, so that the in New Zealand is declining, is showing that overall that the increase in these students is masking an overall decrease in performance of every other student. And then look at this achievement level by decile. Look at what's happened between decile 3 and 4 and 5 and 6 schools over the last 10 years. That's pretty challenging. And what we are seeing is a flight of students from lower decile schools to higher decile schools by parents who can afford to make the transition where they possibly can. And students from 7 and 10 schools are 2 or 3 times more likely to go to university, to get actually university entrance qualifications. The number that actually goes to university is even more skewed. Those are pretty challenging things. The achievement between higher and lower socioeconomic groupings is larger in New Zealand than elsewhere. And that doesn't accord with the way we think about our country by and large. And we all know, every single one of us knows, that these kids from lower decile areas are not less intelligent, they're not dumber. There's nothing like that going on. So there's something in our system which creates this. So how bad can it be? So here's a little bit of data out of the Ministry of Education. Here, let me look down this line, the type of question, multiple choice and constructed response. Multiple choice means a choice of 1 in 4. 27 times 43, we're actually last in the world, 50 countries or so. And I've circled 16 because your pet could do 25%. Random answers are 25%. So there is something about the way we teach these things that leads to this incredibly poor outcome. Just knowing that the last digit of that multiplication is 1 increases your chances to about 50%. So something is definitely going wrong. And look down this column, last, fifth lowest, third lowest, last, third last, third last. And then in geometry, those sorts of things. You look at this data and you conclude that you can't do complex reasoning without a strong bed of knowledge, and that it's a strong foundation in number is required to do all aspects of mathematics and statistics. There's just no way out of drawing those conclusions here. And my observation would be that we need fewer slogans in the education sector and more evidence-based decision-making. The slogans would be, these countries teach rote learning and we teach learning with understanding. Now, how can you against that slogan? But it's pretty evident that we don't actually learning with understanding. We don't actually teach very much at all. And those students who might these things through rote learning techniques actually are being given life skills to help them. Other slogans are about evidence-based or inquiry learning or all sorts of other things, you know, child-centered learning. Well, you know, you don't walk into a classroom and expect very far if there are 20 different centers. I think we have to rethink our approach to a lot of this stuff. And then there's the equity issues. Frequently, the cultural background of both Maori and Pacifica students is perceived deficit within the schooling system. And actually, teacher expectation of the performance of Maori and Pacifica students was easily the lowest. And we saw that data. So whether or not it's an actual thing or a self-fulfilling, those are interesting questions to try and draw out. Teachers referred to the perceived deficits in home backgrounds, attitudes group, motivation, goals, aspirations, and parental support. Well, it's pretty hard to give parental support if you're actually working 2 jobs, trying to make ends meet in a city like Auckland. But decades earlier, when things might not have been so pressing, when housing probably wasn't so bad, exactly the same perceptions were there. So this perception issue that these sorts of students are not going to perform well, that absolutely must be dealt with. It is not true. Perception is there. One of the major things we found in our was this slippage in class. And so it describes how year in year, students just fall away from the trajectory outlined. And this thing, when I first saw it, when it was presented to us by the Ministry of Education through the National Student Monitoring Surveys, fewer than 1 in 14-year-olds are in classes where the majority of their peers are working at appropriate curriculum level. We want to read that again and think, how can that possibly be? 10 are not in classrooms where their peers are working at the appropriate level. This fall off is again evidenced by the NMSSA. About 1 in 5 year 4 students are working below the appropriate curriculum level. Well, that doesn't seem too bad. But actually, by year 8, 4 years later, it's more than half. And that's the panel's view. If students achieve the current curriculum levels and the suggested time frame, they'd be well positioned to succeed in mathematics and statistics and use mathematics effectively in their daily lives. If you look at our curriculum, you look at the pacing of it, and you compare it internationally, it is not fabulous and it's not bad. It is pretty good, and it is at least of international standard. There are no countries whose curriculum is far easier or far harder. Ours is average, and it's actually pretty good. The problems we have in education are not with curriculum. But this low achievement and slow progress is clearly associated with socioeconomic status. I said before, the first line there, 1 in 10. Well, 1 in 10 is not socioeconomic. This slow progress is up and down the system, every level. But what happens in the lower social system, status schools, the trend gets exacerbated over time to where the earlier data that, so few go on to get university qualifications. But this slippage year on year is the problem worse year on year because of the pedagogy associated with it. Teachers have to cater for wide and widening differences in the levels of skill of students in every class. Setting and maintaining appropriately high expectation students and achievement progress is challenging in an environment where you have students from level 1 to level 4 or level 5 in the same classroom. And the evidence shows that that happens in many classrooms. So many students are challenged with this status. And also how and when to sophisticated context to students who seem stuck in earlier material. Those are severe pedagogical challenges. Actually, one of the responses to these pedagogical challenges is to put students into ability groupings. So this is streaming by de facto within classrooms. And this goes on in most classrooms, in most areas in New Zealand, staying both in a zone and so forth, and not moving ahead with new ideas. Slow everybody down. And what that reflects is an apparent underestimation of student potential for progress. New Zealand students aren't dumber than those in America. Everybody would say other, but what we're missing is the structure that keeps moving students forward on the assumption that they cannot do so. This way that we teach and respond to these pressures is contributing to the very problems we're trying to solve. The curriculum's open design encourages local flexibility and provides space for schools to tailor curriculum to their communities. Now that sounds very good, but there's actually no mandated national approach to be followed, maybe. And what is worse is that there's very little guidance for teachers. Teachers are faced with all sorts of different challenges here. The broad year levels allow for the postponement of teaching of important skills and ideas till later. And later keeps happening. And you will know from your own classrooms, I think, where you receive kids 1 year who should have been last year. That's because they should have been taught something else the year before, and this accumulation of delay. So a fundamental contradiction in our system, schools and teachers are afforded the flexibility in maths, but given the support and guidance to use this flexibility in ways that comes in system equity. So instead of producing rigorous learning, this lack of central direction contributes to and introducing more difficult materials doesn't happen as often as it should, and it actually slows progress. But how content taught also impacts progress. Again, this within class ability grouping requires teachers to prepare multiple lessons, creates more work, and actually reduces the contact time any one student has. Divide your 1 hour by however many you've got, and that is how much attention a kid is going to get. So this results in low engagement with students and poor outcomes. And the evidence shows that within class groups offers no benefit in teaching outcomes as these exams are concerned. And actually, it's negatively correlated to mathematics performance in every country. So it's just a bad idea. But that is in part because ability is not actually ability. We never measure a child's ability. What we measure is their preparation. So if students come poorly prepared in their first years, they're disadvantaged forever in our system to any ability they might have. I've taught at university for many decades now. And while I can ease the students who are very well prepared and who are going to do well, it is very, very challenging to identify in those classrooms who the people with real mathematical ability, who are going on to be the professors. And look at myself, nobody would have thought I would have been a professor coming out in high school, going to university. My first year GPA was a C-. How do you tell the ability from the preparation? So usability is really annoying. There are, of course, times when things are best done in small groups. Evidence is that these groups should be mixed up, not necessarily the same ability, but it should not always be like that. In terms of the nature of learning, research suggests that a range of approaches, problem solving, learning to reason and justify, structures, and memorization are effective. Rote learning really does have its place to build the foundations. It won't work for every student, and that is in part why the numeracy development project implemented, because people felt that these approaches to learning weren't succeeding because the system was failing. But it could be that there are other systemic problems. Every really does need to know their times table and have those basics at hand. Quite how they are taught those basics is another issue. So knowing when to use a range of pedagogical approaches is necessary for making content available. Not all kids learn the same. So what happens when we don't make evidence-based decisions? Here are some notes and observations from the NDP. The diagnostic testing tools that were designed to inform teacher planning are actually used to label children. the viewpoint that some students have more to contribute and are expected to contribute more, while less capable students are expected to contribute less, actually became a self-fulfilling prophecy. Those classes that followed the NDP lesson plans isolated computational strategies to over, and that limited student opportunities to progress. So as a consequence, rather than build computational fluency and confidence with early number work, these learners struggled to know which strategy and what to use to how to solve these number problems. That is why you see that 27 times 43 being less than random. Too many strategies, students not knowing what to do. Adopting strategies where you give this and take that, so forth, meant that they couldn't even see immediately that the last digit was 1 to check their answers. So while the NDP provided some useful insights into learning progressions, implementation was short on support for effective pedagogically and lacked oversight. So I mentioned this while we were waiting for you guys to come in, but this is the road to hell. There are seriously good intentions put together by people who know what they're doing. They had good intentions, but the road to hell is paved with good intentions. There was no oversight. And when things started going off the tracks, things were not able to be put back. So we went in this direction for 20 years. Low support, maybe initial support, but over time that waned away. So there was no evidence for these changes. Just a lot of people thought that this would be a good idea. My question to you, does anybody really think all these issues, or even the most pressing ones, will be addressed by tinkering with NCEA and the curriculum? Why this matters? Well, you're all math teachers, so I hope you know why good mathematics education is key, but I will tell you. I mean, improving individuals' life outcomes is the key goal of education. There are the individual goals, but there are also societal goals. Our businesses, our country needs people with higher level, economically valuable skills that will shape our economies. And it's an increasingly globally competitive economy. Nobody actually gives a rat's ass how New Zealand is doing. We have to do it for ourselves. STEM and mathematical skills drive innovation, and they're going to be crucial. Everywhere you look, there's a steady shift away from manual and low-skilled jobs to those requiring higher levels of management expertise and problem-solving skills, many of which are mathematical in nature. Now, we don't teach simultaneous equations or quadratic graphs because we think those are important things for people to know when they're doing their job. We teach those things to give kids an understanding of process, of algorithms, how to think around problems, how to extract information, how to put together things, how to solve problems. That is what your mathematics education is about. I mean, I keep saying that as a student, I learned how to integrate x sine x, different ways, many times over. I'm a professional mathematician. How many times in my life do you think I've had to integrate x sine x? Well, almost exactly never. I didn't learn what that integral was because I needed to know what that integral was. I learned that integral, so I'd be understanding the processes of how to solve problems, how to manipulate equations, how to bring data and other things I knew to the table. Employees also emphasize that the importance of people having studied mathematics at a higher level than they would actually use. So that provides them with competence and versatility to use mathematics in the unfamiliar situations that occur at work. This is not in New Zealand. This is repeated in international studies. So employers want mathematics at a higher level than they actually use. And I think that goes for teachers. Adults with poor numeracy skills are characterized by employment trajectories of the following type: leaving full-time education early with no qualifications, patchy employment, periods of casual employment and unemployment, and jobs low skilled, poorly paid, and basically no opportunities for promotion. I will not tell you about the other statistics. There's a long-term study being run out of a group at AUT of the other consequences of poor numeracy. The chances of you interacting with the penal system are many times more. Your health and wealth expectations are completely blown away by poor numeracy. It is a really serious problem. And each of these trajectories carries negative economic impacts for the individual, not just for the society. We build ambulances at the bottoms of cliffs for these people. Poor numeracy carries a larger penalty than poor literacy. If you talk to employers, they believe that, in fact, literacy skills can be taught on the job, whereas numeracy skills cannot, by and large. Those are studies from the UK and Australia, and actually the penalties for poor numeracy are harsher for women than they are for men. One of the things that we looked at was teacher discipline and pedagogical knowledge. Very few primary teachers have specialised in mathematics. 14% of Year 5 teachers have specialised, but studies have repeatedly shown that teacher knowledge well beyond the student level is essential to answer questions meaningfully, to make connections, to talk even about the wonder of mathematics and why it's interesting, why it's important. So building and maintaining high levels of teacher content knowledge is a long-term challenge that simply must be addressed at a national level. Evidence from ITE suggests that a majority of candidates going into ITE can't answer mathematics questions for curriculum, I can't see my slide, level 4. So that is a challenge. And this is a long-term challenge that's been going on for years. Every year, year on year, we get the same data saying the same thing. The magnitude of the difficulty is exacerbated by negative experiences and attitudes in some teacher candidates. They didn't have a good experience in mathematics through their education, but they wanted to be a teacher. They go through the teaching process and they want a job, and they find out, where are the jobs? Well, they're as mathematics teachers. There are challenges all over the scope. Leadership. The current state of mathematics and statistics education is the outcome of a system and not the product of individual failings, not one teacher or 10 teachers. It's not one person in the Ministry of Education or 10 people in the Ministry of Education. But this systems view has implications. There's a need for a more centralized approach to support and coherence and clarity around teaching and learning. So we have to address the problem of significant numbers of underprepared teachers. At the moment, I think the panel was aghast to learn just how little mathematics teaching goes on in ITE provision. Something like 12 hours of actual mathematics instruction over a year for people who may not have done mathematics since the form. And actually, we need to simplify the selection and delivery of supporting materials written by pedagogical experts. Teachers are unsupported by and large to choose from a vast array of material, some of which is evidence-based, much of which is not. Teachers and schools will make decisions on the material they present based on who was the best salesman who showed up at our school at that time. That's not the way to run a national system. So here are some of the first steps forward. Ensure every child is given a quality opportunity to learn mathematics, at least an hour a day. The evidence suggests that mathematics are the most often skipped classes in schools. That's because of teachers' perception that it's the classes that the kids like the least. So you want to reward them, you skip your mathematics class if something else is going on. Don't do it. Material that is learnt has to be authentic, relatable to the children, and challenging. We have this deficit theorizing in New Zealand about what kids can't learn and when they can and can't learn them. It's not correct. We believe that named career pathways with associated remuneration and genuine time allowance and financial support should be there to upskill teachers. It's no use saying, yes, teachers have to upskill, go and do it. That won't work. And the Ministry of Education knows that won't work, and it knows it won't be cheap. And so maybe that's why we have seen no progress on this for decades. But we also have to clarify what students need to be given the opportunity to learn. This slippage in our system means that lots of students are not even given the opportunity to learn some of the things they need to know. Primary schooling, there's been a strong focus on teaching numeracy in the numbers strand. None of these strands are optional, so they all have to do them. But there's a choice to teach these at different times and different years. So what happens in practice, unless the schools have a clear and focused plan to assure curriculum coverage, a lot of these things don't actually get met, even though they're in the curriculum. Year 5, about just a bit more than less than half had the opportunity to even do things like compare or draw angles. Less than half, they were able to engage with perpendicular lines and those sorts of things. In year 9, 1 in 7 students were given tasks involving strategies for simultaneous equations, a third with simple tasks around linear equations, but that's in the curriculum at that time. Most of the students are not getting it. So we have a whole system challenge. We need to improve funding for research to make sure that we make decisions, develop strategies that are evidence-based. System structures need to be purposefully designed to support the development and sustainability of our education system. We need to strengthen the support infrastructure for teachers and the alignment and coherence in the system. We need to develop Mathematical and Statistics Education Institute. We need a structure to look at what's going on, try and set things back on the rails if they can. We need to increase postgraduate mathematics and statistics education by giving opportunities for teachers. Maybe scholarships, but definitely time. We need to strengthen open access, equitable dissemination systems for teachers and policy developers. We need your shared experience about what works and what doesn't work more available. We need to develop leadership networks amongst the teachers to evaluate resources for schools, build up some evidence about what works and what doesn't work. We need to address the problem of significant numbers of underprepared teachers in mathematics. We need to simplify the selection and delivery of excellent supporting material. It needs to be looked at and delivered by pedagogical experts. And we need to support teachers in choosing the right stuff to present. To finish up, I have a couple of more questions actually. And I wonder if the good intentions around localization of the curriculum have gone too far, with localization damaging the ability of the curriculum to be equitable and nationally coherent. And I also wonder, in particular in light of your later discussion today, will the socio-political changes, good intentioned, but almost never evidence-based, drive more inequity into the system with flight from NCEA by those who can afford it? We've already seen that that is something that has been happening. Will that continue? So thanks for listening, and good luck with our future. Thank you.